Hey everyone, welcome back to the channel. Today we are going to discuss an important technique for database scaling called replication. Replication can help you achieve high availability, better performance, and ensure data reliability. As your user base grows, in this video, we will cover what replication is, why it is important, different types of replication, and best practices for implementing it effectively. So let's dive in. First, what is replication? Replication is the process of copying data from one database, which is a primary database, and here is the source, to one or more databases called replicas or secondary databases. This helps distribute the load, improve data availability, and protect against data loss. Think of replication like making backup copies of your important documents and sorting them or storing them in different locations. If something happened to the original, you still have their copies available. Okay, so why use replication? The first thing is high availability. High availability is one of the main reasons to use replication. If the primary database goes down, a replica can take over, ensuring your replication remains available to users. For instance, in a banking application, it's crucial that users can still access their accounts even if one server fails. By replicating data, you can have a seamless failover mechanisms to ensure continued availability. Second, load balancing. Replication also helps with load balancing by distributing read operations across multiple replicas. This way, the primary database can focus on write operations while the replicas handle most of the read traffic. For a social media app, you can use replication to distribute the load. All read requests like loading a user's profile or fetching their posts can be handled by replicas, reducing the load on the primary database. Number three, data redundancy and disaster recovery. Replication provide data redundancy. If something goes wrong with the primary, you have up-to-date replicas to fall back on, which is essential for disaster recovery. Imagine your main data center experience an outage with replication. You can switch over to a secondary data center, minimizing data loss and downtime. Okay, we have types of replication. And first thing we will talk about, which is the synchronous replication. Synchronous replication ensures that data is written to both the primary and replica simultaneously. This means that as soon as a write operation completes, both databases have identical data. Synchronous replication is great for strong consistency, but it can introduce latency since the primary must wait for confirmation from the replica before completing the transaction. This approach is often used in financial system where data consistency is critical. And this is how it works. First, we write a query. Write query comes from the application. Second, write data is written to the primary code and to the primary node or the primary database. Third, the write data is queued for replication. And fourth, write data is sent to replica node. And five, the write data is written to replica node. And five here, this is happening. Six, the replica node sends a confirmation to the primary node. And lastly, the write data is committed to the primary node and sent back to the user if the user sent a read request or something like that. On the other hand, there is the asynchronous replication. Asynchronous replication means that the primary database completes the write operations first and then propagates the changes to the replicas. This is much faster, but comes with the risk of lag between the primary and the replica. Asynchronous replication is commonly used for application where availability and performance are prioritized over absolute consistency, such as e-commerce websites, where some lag in inventory updates might be acceptable. Okay, right now we want to talk about the challenges of replication. And the first thing will be data consistency. With asynchronous replication, there can be data consistency, data inconsistency if the primary fails before changes are propagated to the replicas. This can lead to different replicas having slightly different versions of data. For example, in a distributed inventory system, if an update to stock levels isn't propagated before the primary goes down, replicas may show outdated information, leading to potentially issues with stock availability. Number two, we have increased complexity. Replication also adds complexity to your infrastructure. Managing multiple replicas, handling failover, and ensuring data consistency can be challenging, especially as the number of replicas grow. For instance, ensuring that all replicas are synchronized during failover or maintenance require additional tools and careful planning to avoid any service interruptions. Right now, we will talk about the best practices for implementing replication. First will be monitor replication lag. Monitoring replication lag is essential, especially with asynchronous replication. Tools like CloudWatch can help track how up to date your replicas are compared to the primary database. Use replication for Redis also. This is the second thing of the best practices. Where possible, where possible, use application for Redis, direct read operations to replicas, and keep write operations focused on the primaries. This setup reduces the load on the primary database and makes it better use of the replicated data. And three, which is to plan for failover. Implement automated failover mechanisms so that when the primary fails, one of the replicas can take over immediately without manual intervention. Using managed services like AWS, Amazon RDS, or Google Cloud SQL can simplify the failover process. So to wrap up, database replication is a powerful technique to achieve high availability, distribute read loads, and ensure data redundancy for disaster recovery. And understanding the types of replication, synchronize and asynchronized, and planning for challenges like data inconsistency and complexity will help you leverage replication effectively. If you found this video helpful, be sure to like it, subscribe, and hit the notification bell so you'll never miss any video. And see you in the future.